When we think of social engineering, this is the assumption we have to make. Don't trust the humans. The humans are compromised. Now, if we work on that assumption, how can we properly protect our systems? This brings us neatly to separation of duties and the principle of least privilege. Now, what we're going to cover here is actually advantageous in two very different scenarios. One of them is social engineering, and the other is intentional malice. So on the social engineering side, what we're aiming to do here is to protect systems from people who have good intent, but then fall victim to something like receiving a malicious email. They might open that email and it contains malware, which attempts to compromise a system, but that was never the intention of the victim. They didn't set out to compromise that system. It's just that someone else was able to successfully get that malicious email through to them. Same again with browsing to a rogue website. So what if they go to a website which delivers that malware? Or another good example is when they're the victim of human-based social engineering. In these three examples, the damage is done by someone who had no intention whatsoever to do that damage. It simply occurred due to the level of access they had and the fact that they'd been socially engineered. Now compare that to intentional malice. So for example, there's a disgruntled employee. They didn't get a pay rise, they don't like their boss, they've lost faith in the organization. Something has happened to upset them. Alternatively, it may be that they have financial motivation. So for example, someone says, hey, get us this piece of data from inside the organization and we will pay you money. These are both examples of intentional malice. The individual within the organization is setting out to do something that they know they shouldn't do. Now, whilst these might be two very different threats, separation of duties and the principle of least privilege provides a way of defending against both of them. Let's start by looking at separation of duties. What we're talking about here is requiring more than one person to complete a task. You might sometimes also see this referred to as segregation of duties, in that one person can only do part of the task, and the other person or multiple other people are required to do the other parts of the task. By doing this, what this means is that you have to have multiple people complicit together in order for a compromise to take place. Now, of course, that's possible. You could have duties segregated across multiple people and they work together to do something malicious, but it does make it significantly harder. Let me give you an example of what separation of duties looks like. Let's imagine we're talking about publishing code to a production system. Now think back a couple of slides to where I was talking about social engineering and malice. So imagine, for example, you have a coder in an organization who decides that they'd like to start distributing malware via the company website. Let's take that coder and imagine that they can publish directly to the production server. There is no separation of duties here. You've got the one person who, if they turn bad or are convinced by an adept social engineer to perform their bidding, can get that malicious code all the way through to that production server. Now let's roll that back and instead look at what would happen in a separation of duties environment. The coder would write the malicious code, but they would need a release manager in order to actually push that through to the production server. So now these guys have to be complicit. The two of them have to work together in order to get that malicious code into the production server. This is the principle around separation of duties. However, I will say this. The value proposition of separation of duties only works when the release manager is actually aware of what they're releasing. Unless that person is actually having a look at what the coder did, the coder could write all the malicious software in the world and the release manager would simply push it. So that guy has to have accountability. And in order to have accountability, he has to be able to review that coder's work and ensure that it's not doing anything malicious. I've seen environments in the past where they very proudly say, yes, we have separation of duties. We have a coder and we have a release manager, and it takes the two people together in order to get the software through to production. But it was nothing more than a facade, because all the release manager did was push a button. And whilst automated deployments are undoubtedly a very good thing, in the context of separation of duties, that release manager did not add any value to the process. There wasn't separation of duties in any practical, useful sense, only on paper. Let's go and have a look at another approach to minimizing the risk of social engineering or intentional malice, and that's the principle of least privilege. I talk about the principle of least privilege quite frequently in my courses, and the premise is really fundamentally simple. Only give people or programs access to what they need in order to perform its legitimate purpose. That is a very basic principle. If someone doesn't need access to something, don't give it to them. I heard a very good example of why this is important recently. Someone told me the story of an old manager who insisted on having all of the rights that his direct reports had. His rationale was, I can tell them what to do anyway, I should have all the permissions that they have. And he did. And one day, he brought his young child into the office, who then used his computer and erased things on servers that the manager never actually needed access to, because in his mind, he had control of it anyway via the reporting chain. But he did not need it, and if the principle of least privilege had been applied, he wouldn't have had those access rights. And when his son came into the office, he would not have been able to delete the files. Now that's a perfect example at the access control level, but it can also be applied to how we design systems. Let me give you an example of that. One of the problems is that we often design systems so that people have access to excessive information. I'll show you what I mean by that. Let's imagine we have a customer and we have a help desk. And the customer calls up the help desk one day and says, hey, I've forgotten my password. In many systems, the help desk is able to respond by saying, hey, I'll just look it up for you. Now what this means is that the help desk has access to people's passwords. A system would be designed this way because the architect is thinking, the way I will solve the problem of someone forgetting their password is I'll create a way for the help desk to retrieve it. But the problem with this is that once the help desk can see passwords, then they may be socially engineered into accessing passwords, or if they turn bad and they exercise that intentional malice that I spoke about before, they could start to retrieve passwords that they never have access to. Let's roll this back and have a look at how the principle of least privilege would change the design of this system. So we'll take the same scenario. Customer calls up and says, hey, I've forgotten my password. What if the help desk, instead of having access to the password, could turn around and say this? Let me send you a reset link. This would mean that the help desk wouldn't have access to the password, but they could still support the customer. They could still help the customer solve their problem. A moment later, the customer gets an email with a unique link, which they click on and then set a new password. Now, of course, this also means that the passwords could be stored properly as secure cryptographic hashes rather than sitting there in plain text or merely being encrypted, which is what would need to happen for the help desk to be able to actually see what the password was. But as well as that, this is just a great example of how we can build that principle of least privilege into the fundamental design of our systems. Let's move on and have a look at something else we can design into our systems, and that's how we do verification.